content. And by doing that, we can do bulk vetting of large entities. So if you're a bank and you have, and by doing that, we can do vetting of large entities. So if you take that 20,000 people, you put that into our platform, we have and by doing that, we can do vetting of large entities. So if you take that 20,000 people and you put that into our platform, and by doing that, we can do vetting of large entities. So if you take that 20,000 people and you put that into our platform, and by doing that, we can do vetting of large entities. So if you take that 20,000 people and you put that into our platform, and by doing that, we can do vetting of large entities. So if you take that 20,000 people and you put that into our platform, and by doing that, we can do vetting of large entities. So if you take that 20,000 people and you put that into our platform, and by doing that, we can do vetting of large entities. So if you take that 20,000 people and you put that into our platform, and by doing that,
or companies that screen per day. All right, so another portion of this is data integrations. So aside from the cool models that our data scientists build, we deal with a lot of data from partners. One search may hit 5 to 20 different data sources, and the system is dynamic. Each organization's query plan can be different. Again, not just domain, but also sites and data sources we bring in. So inherent in that use case is that each search will only be slightly faster than its slowest data source. Each partner is different, but most of them limit their service by way of queries per second. You can buy more, but bottom line is you need to take that into account when building the architecture. So with all that, we have to build a system that's capable of dealing with flexibility when a partner or source fails. And traceability becomes key in that architecture, quickly being able to diagnose errors or performance in any one of those stages. Security. Security is very important to us, primary architectural concern. Good security posture includes capabilities such as threat detection, packet inspection, network design decisions like isolated environments, VPN-only access, key rotations, time-limited access keys, and strong process-related items like regular penetration testing, strong MFA. All right, that was all the architectural challenges. Any questions on that? All right, operations, infrastructure, and monitoring. So we don't have any dedicated operations team at Giant Oak. We follow the Google SRE model, where engineers do operations. And so with that, it kind of forces the organization to balance the operations overhead with automating it away. Our data scientists are writing model code in Python. They're persisting models in Python. And so that sort of influences how we're going to deploy, which execution environment we're going to run the application in. And by choosing Python to run our architecture in, it means that the scientists can also come and help with application issues if there are issues. It's familiar language, syntax, etc. All right. We serve both the government and financial institutions, so that means double the infrastructure. We deploy both to GovCloud as well as US East and AWS. Lots of data integration, so from an operations perspective, we have to develop the infrastructure to have the most efficient data paths, both for performance and cost. If you guys have dealt with any applications that move a lot of data around, you pay a different amount between availability zones, regions, etc. And availability. Obviously, we want a very resilient system, but also Ghost is expected to be there 24/7, 365. We've got customers around the world, so availability is key. High security and compliance requirements. So we spoke a little bit about some of the building blocks for security in the architecture section, but from an operations perspective, we have to have solid process, policies, and procedures in place. Risk management, around things like risk management, information security, access controls. There's a ton of this stuff. Luckily, we've got a pretty talented security architect, so he takes care of that. We're looking to be proactive when it comes to privacy. It's inherent in our business, and often we're liable for the same compliance requirements as our customers. So financial institutions have things like GLBA or FRCA. Everybody's being accounted for GDPR these days. All of that falls on us. Nature of our business. Okay, ready for a quick intro to model development? Now everybody wakes up. We're doing this to have some fun, but give you some context into what the science team here is building in terms of models, so we can relate that back to the architecture. And another one. Intro. Okay, so the Giant Oak science team is primarily concerned with two problems, both of which depend heavily on modeling natural language. It's entity resolution, content classification. Entity resolution focuses on finding records that refer to the same entity across different data sources. with the goal to reconcile customer-provided information with PAEI. That might not be obvious, excuse me, obvious in the beginning, but a customer may give us a name, an address, phone number, an email, something like this. It may or may not be all accurate. They may have given us a wrong date of birth. They may have given us a wrong email, but the right name. We reconcile all that during entity resolution.
Sorry, real
Yes, sir.
quick. Publicly available
Electronically, electronic information. Yes. I had the same question.
Well,
The classification.
we're not gonna go carve paper copies, so we're not gonna go call these. So that's why we threw electronic in
Somebody can upload it. We're good take it. But.
there. And it's electronic.
Right. All right, so then content classification, which is requires identification of different types of information about human activity, for example, money laundering, human trafficking, across large data sets of unstructured text. Questions? Okay. We're going to use the iris flower example data set. If you've taken any machine learning courses, you've probably seen this in Sci-Kit Learn. We'll load fit, persist the model. The data set is 3 different types of irises, the petal length and sepal length, stored in a 150 by 4 NumPy array. This is the principal component analysis of that, where you can see the dimensions. It actually breaks out the various flowers. Rows being the samples and the columns being length, width, like we said. Data set in Sci-Kit Learn is a dictionary-like object, holds all the data and some metadata about the data. I had to practice that one a few times. Can you see that? So the target names are actually the flowers, right? The iris features are length and width, and there's the array with all the samples. Okay, using a simple support vector machine, we fit the model to the iris data. Then save that model in Sci-Kit Learn by using Python's built-in persistence model, Pickle. Right, so you see it here. That's your classifier. There it is being persisted. Very simple. You should persist those things. Compress them when deploying them. I put a note here. There's a library called JobLib, which is a replacement persistence library for Pickle that works pretty efficiently on arbitrary Python objects. Big NumPy arrays, basically. Any questions? That was super quick, and I admit it. It was on purpose. Because what we're focused on here isn't really that, but the deployment model, the AWS, and all that. Those models, never mind. So watch previous, if you want to learn more about Sci-Kit Learn, watch the previous DC Python presenter, GitHub Joanna Kochuniak. I hope I said that right. Intro to Machine Learning in Python. She did it a couple of months ago. Goes into good detail. So, okay, what's the deployment look like? Okay, so overall, the solution is serverless and hosted databases. It's built in the cloud, obviously Lambda for serverless. We use RDS, Elasticsearch, and Elastic Cache for all of our hosted databases. There's a ton of automation with Ansible for provisioning the app components, Jenkins for building and packaging, and Rundeck for operations and deployment. Stop me at any time with questions. Yes, sir.
Why not something like Terraform over Ansible?
Terraform over Ansible?
Yeah.
Remember that Python platform? Ansible's all Python. I think that's why. We actually now do have a lot of Terraform in the platform, but it was brought in by our security engineer and not really application team.
And also 4 years ago, Terraform was new, 1, and 2, most of our architecture at the time wasn't serverless because Lambda was still new. So there was a lot of EC2 configuration, which Ansible does much better than Terraform. Actually built, you do Terraform typically to instantiate the instance, and then Ansible will go in and install your packages, set up your security profiles.
why the Ansible install.
Because it was easy. Had to learn something.
Yeah.
Cool. Anybody else?
So I have a question. So you're building a serverless infrastructure, and yet you have infrastructure to manage that. So are you guys thinking of changing that to make everything serverless?
And the infrastructure you're talking about is Jenkins and Rundeck?
Yes, yeah.
Yeah. There's a little bit more as we'll go on that you'll see. Moving everything to serverless would be yet another big effort, and so it's a balancing act. Okay, lessons learned from deployments and packaging. So, simple deployment model S3. For the most part, if you're doing Lambda, you package up your Lambda function, you stick it on S3, it picks it up, it executes it just fine. The lessons here is your package cannot be more than 50 megs zipped up. It cannot be more than 250 megs unzipped, including layers. You can work around this somewhat with a /temp directory that you get on deployment. It gives you an additional 512 megs. Okay? That means you can load those models down to that temp directory at runtime, which we'll talk about later. Any Python library that loads a C shared object at runtime, things like pandas, Sci-Kit, it's like my formatting got messed up. But you must build a binary specific for that AWS Lambda execution environment, specifically Amazon Linux. Make sense? Chromium is another good example. So a lot of the web scraping that we do is driven by Chromium's the headless browser, Chromium. And so getting that binary to run in Lambda requires building it specifically for that environment. But it's also too big, so you have to pull it down at runtime. It's kind of a pain. Questions?
Yes. Sorry. Can I conclude from your lesson section that Lambda is really use case specific, so you can't really run large applications on it because they have to be a certain size? And although it says serverless, but it's not all purpose. Just run very small scripts, and it has to be under a certain size for it to be serverless.
Yeah, I think that's
Yeah.
the conclusion I've come to, is that it's actually really good for simple use cases.
Yeah.
It's good for small models and small processing ability.
Right.
And a lot of that has to do with the actual resource constraints that are there.
Yeah.
Not just what we were talking about a second ago in terms of the size of your package, but here,
Yeah.
right, Lambda itself, you can have only up to 3 gigs of memory. Anybody develop models, I'm sure, like you're going to use more than that.
Yeah.
Disk space, again, you got big models or big data sets you need to operate on. ENIs, this has actually gotten a lot better, and Roy might stand up and just kind of vent for a while. But ENIs themselves, so your Lambda function only requires an ENI if you're going to access another network resource. And that's another private VPC you might access a resource from, or RDS, or the internet, doesn't matter. If you're going to access a network resource, you need an ENI. And prior to a couple of months ago, there were very strict caps on those ENIs, and we would have a lot of processing problems because of ENI exhaustion. One of the things.
What an ENI is? Elastic Network Interface. So basically, it's a NIC,
Yeah,
virtual NIC.
right. It's attached to your Lambda at runtime, right?
Could you tell us about your VPC setup for your apps?
Sure.
Yeah.
Probably after the presentation you got it, but.
Yeah. Yeah, I was just going to relate back to the beginning. When we talked about isolated networks, a lot of that is done by separate accounts, separate VPCs, and AWS has a tool called Transit Gateway, which then lets you pull all that together for packet inspection. That's what we do. Okay, so now I think the ENIs are actually per VPC, so AWS has made that.
A quick question. Are you guys running your own, did you define your own custom runtime that has sort of all the dependencies that you would need like Chromium? Or are you just using the base sort of Python version of it?
We're using.
I mean, when you define it, when you load a Lambda function, you have to choose your runtime. So and from a Python perspective, you only have 2, 7, and 3 sticks, I think.
So I think you can define your own custom one.
Yeah, no, we just go with Python 3.6.
Because I know some people wanted like Rust for a while, but Amazon didn't provide like a Rust runtime.
Yeah, no.
And then so you could build your
They're
own.
slowly adding them,
Yeah.
I think, yeah. But
Yeah, we've taken two approaches: layers for reusable components, and then loading things at runtime via the application. Okay, so execution time. You only get 900 seconds, and accounting for things, if you're doing networking things in Lambda, accounting for that, like timeout values, the startup time of Lambda, processing time, 15 minutes can go like that. The other thing to keep in mind that I don't even have captured here is when that timeout happens, your application is severed. Like, there's no graceful stop, there's no like wind down time, it goes away. The logs don't indicate, anything about the failed search or why, what happened. It just gets severed.
So if you have a job that's over 15 minutes or like even like 15 minutes, if the script is long, then you can't run it on Lambda, right? Because you can't.
You have to work around it somehow. And if you want to build into the application that ability to maintain state across those executions, maybe you could do it, but it's not, yeah.
Do they kill the container or do they freeze the container where it gets reused the next time? So,
to kill the execution, the instance still stays around, so if you make an immediate call, you might get the same state, but it's not guaranteed. Especially depends on what's feeding your Lambda function.
is there a way to batch these Lambda servers so that you have more than 15 minutes?
No, you get 15 minutes.
But if there is another previous one, can't we restart the old process that was just frozen?
I mean, you have to save state. You could write to that temp directory and hope you get the same instance next time it's called, but that's not guaranteed.
Okay.
And you'd have to play some really weird bottleneck constraints, like set your reserve count to 1 so that you only have one instance running, which kind of creates an inherent bottleneck. Right, what you want to do if you're using Lambda.
So I guess this, do you just run small batches? Is that the workaround? Or
No, I think the workaround is to make sure that each component is small enough, processes fast enough.
Yeah.
If it doesn't, that's your red flag.
Yeah.
Start breaking it down or consider another execution environment.
It's a function, not an application.
yeah, exactly.
Yeah.
Yep.
Well put.
Also, in those cases, I would say, like, EC2 can still be valid. So if you're really needing to run something for that long, then AWS might just recommend just
Yeah,
using
exactly. EC2. Or even like Jenkins, coming back to that question earlier. Jenkins is being an application, you need to run it in an EC2 instance.
Right.
You can't go serverless for those reasons.
Right.
Yeah.
What we tried to do in that case, actually, now that you mention it again, I remember. So ECS Fargate is a way to do that, as long as those applications support running on Fargate, and there's no persistence requirements, things like that. Right.
We're actually shipping part of our architecture to UCS Fargate because of some of these Lambda constraints that we're having.
Yeah. Yeah.
Isn't Fargate extremely expensive? Isn't it better to just have a EC2 instance?
Depends on what you're doing, how long you're up and running. I mean, that's kind of both, the balance, right?
So Fargate is always a type, right? So you're paying.
No, Fargate is serverless. You're thinking EC2. So ECS, the container service, has 2 nodes. You can run EC2, which is basically just EC2 instances running Docker containers that you manage. Or Fargate, which is serverless. And in that case, it's just on demand. You specify the minimum number of tasks, so we'll always have one minimum number, but you can set up upscaling groups on Fargate, like monitor SQS queue. And as the size of the queue gets bigger and bigger, you can start scaling up your ECS Fargate instances to start handling that load. And then likewise, you start shutting down when the queue starts running.
All right, so the last two resource constraints here, concurrency limits and invocation payloads. Concurrency executions are 1,000 across the region. And that's, doesn't matter which VPC, which availability zone, it's 1,000 per region. So a mistake that we made early on was integration, QA, production were all in the same region. And so concurrent executions would impact production, development, etc.
You can increase the limit if it's off AWS.
You can.
Sure.
You can. But I'll tell you, in a fit of rage, I requested 5,000 and they said no. So.
If you start requesting more and more, they start requiring justifications, and kind of like your application has to fail before they start giving you the additional resources.
Yeah, and the real way around that is to set concurrency execution limits on your function. So kind of understand the workload of your system, either let it scale dynamically or just limit it. Invocation payload. So if you execute from one Lambda to another, and you do it synchronously, that payload can be up to 6 megabytes. If you do it asynchronously, then it gets incredibly smaller. You can only send 256 kilobytes. All right. And serving Sci-Kit models with Apache, it's really pretty simple. We just have an Apache server running. If it gets overwhelmed, you can put it behind an ALB. During deployment, the models are deployed onto the server, and at runtime, the Lambda functions will load any number of those models for processing. One thing that I haven't really talked about here is when the searches are run through the system, there's something that we call a query plan, which identifies that domain that we're talking about and which models to load, which ones to execute, and in which sequence. Question?
S3 was unreliable for hosting of models?
I thought somebody would pick up on that. Yes. So very fast, efficient way to serve models is Apache. S3 was unreliable. We do operate in GovCloud, and so a lot of our decisions can be influenced by trying to keep consistency and dealing with the subpar region that is GovCloud.
I mean, part of that is just, one, S3 is slow in nature, and two, AWS's general paradigm is, we're going to error, you just need to retry. So when you're trying to set up a couple gigabyte model file and you're trying to do it in a timely fashion and connections keep terminating for no reason, and you got to restart that download again, it's kind of annoying.
And you only have 15 minutes.
Yeah, and you've only got 15 minutes, so it's like, I need models, I need them now. Can't wait.
All right, so one of the
My bad, but how slow was the S3 compared to EC2?
slower.
Like multiple times? Okay.
Yeah, I think it's not only the performance, but the reliability, where you have to keep retrying. And imagine this problem where we're managing multiple pipelines. Each one of them have their own considerations, whether it's queries per second from the data partner, failures internally from AWS, and you have to build some sort of retry recovery capability into that system, right? So simplifying that, removing one of the reliability issues, and paying a little extra cost, like having the EC2 always on, is the right solution.
They have different types of objects or buckets, or the standard, that doesn't help with this?
I don't think so. I'll tell you, I think the reason is, so S3 can be accessed by your VPC in one of two ways. One, it goes out to the public internet, it comes back in and hits S3. Or you set up what's called a private link, and then you get almost direct access. We haven't looked deeply into it at China because we have a solution and it's relatively inexpensive and it works. But my guess is if we go in and we did a deep dive, that would be the case, that we're still accessing S3 out to the public. And if we just make it a private link, it would be much more.
Thank you.
Yep. All right, so in summary, it works well as long as the startup time for Lambda, the fetch time for the models are acceptable, and the disk requirements are less than or equal to 5 or 12 minutes. Any questions, comments before we go into?
Two, having to do with serving from Apache. Not in Nginx because the models are too big for cache, or just because people like Apache?
Nginx is a proxy in my mind, and that's the use case that I think about it for, not necessarily just serving up files. Did you have a response to that?
Yeah, the developers set it up in Apache.
Yeah. And the other one is thinking serverless-ishly, EFS.
Yeah, so we thought about that. Just haven't really gotten around to it. Like I said, this is a solution that's been in place for a couple of years and it hasn't caused a problem, so why screw with it?
Is EFS in GovCloud?
Huh?
Oh, it might
No,
not.
ECS might not be GovCloud.
Yeah. Most of the newer cool stuff, you're gonna get to play with in government.
How are you guys deploying the Lambdas?
Ansible.
Okay.
With, Rundeck.
So
and
Jenkins
Ansible.
builds a zip file, copies them up to S3, and then Rundeck runs Ansible scripts to deploy them.
So just curious, how much is still spent approximately, and have you guys able to save some money over the years, figure out a way to be cheaper? Because it seems like you do have a complex stack and it could be expensive.
Yeah, so when we first started, right, 3 years ago, well, 5 years ago when we first started, like I said, our first architecture was basically EC2 instances running Docker containers. This is before Kubernetes became popular, so we were using Swarm. It was really expensive because we had to have enough hardware up to manage our peak time. That's why we went to serverless. So there was a huge savings.
Like percentage-wise, like, could you?
I'd have to go back and look now, but I mean, easily 50%.
Okay.
All right, scalable systems design. So back to the architecture. Remember the objective was to build it to operate cheaply and to scale on demand. So scalable systems design is all about breaking down things into individual components, scaling and failing independently. Each one of these areas, so the network load balancer, the application load balancer, ECS itself, the model servers, Lambda, Elasticsearch, Postgres, all can scale and fail independently in this system. You can see that. Overall, we want the system to operate as fast as possible, but reliably. That requires what we were talking about before, building in these retry capabilities, scaling on demand, that sort of thing. When one area of the product scales or fails, it can overwhelm another. One of the biggest challenges that we've had is if the Lambda functions scale very wide, they'll just overwhelm the database with database connections. And how do you deal with that when you're running independent processes? You now have a cache of database connections you can fetch. So limiting that execution, the concurrent execution on your Lambda functions that require database access is a good way of managing that.
So which process controls that? And can it sort of run that? The number of concurrency?
It is an AWS configuration setting on your Lambda.
Okay.
And so for us, that's Ansible. Huh?
So you set that based on your Postgres instance?
It's kind of a whole system
Okay.
analysis, but yeah, that's one of the things is, how big is my database, how many connections do I think it can handle? Because you may have, I don't know, in our case, 15, 20 different Lambda functions wanting to access the database. You can't scale them all the same way. We spin up 100 of them each, that's 1,500 connections suddenly in the database at each time. Unless you have a huge database.
It's not going to work.
And I assume you have the whole stack for each customer, and they don't
No.
share?
No,
Or
sir.
you have one for everyone?
Yeah.
So I don't know so much about serverless databases, but isn't the value prop for Aurora to be sort of your traditional serverless database so you don't run into like these limitations? Okay.
I think Dynamo is probably a better use case for this. And Aurora and the whole serverless aspect there, or the serverless access, is relatively new. And again, not in the cloud. So, again, I do think that DynamoDB is a good database for this use case. But again, the application's been built, it's been operating, if we're going to do that evolution, it's just going to take some time. All right. Okay, centralized logging and monitoring, that's what's next. So, any questions on this before we go? Any further? Okay, logging. You have to have centralized logging. In this example, we're showing CloudWatch, our CloudWatch logging infrastructure. This top represents another account. So there's two different accounts. And if you're going to use this kind of approach, you have to do something called a log subscription to a log destination in another account. And then all of that can be fed through Kinesis. Kinesis is used to throttle the logs to that Lambda function, where it'll automatically send it in batches of 100 or 500 or what have you. Everything is logging JSON messages with standard Python logging, which makes it real easy for it to flow through the system. And our logging cleaner here is there to transform any messages that are not formatted properly or need to be cleaned up somehow.
Do you maintain a request ID for every request that passes through your system? Like how do you track a single request?
We do actually. It's called a message ID. And so every function that's touched, every thing that happens gets logged with that message ID.
And that gets, where is it created? Like how is that tagged to that request?
It's created in the...
First line function, it creates it, but it doesn't exist.
Yep.
And it gets persisted in the database.
So it's part of the search metadata.
Question?
Sorry, real quick. For the logging, do you guys log to standard out or to file, or how does it work?
Depends on...
I mean, you don't have a file if you're in serverless world, so the way AWS typically handles it is it takes your standard out and funnels it to
Okay, so they provide that.
CloudWatch.
Gotcha.
By default, that's why everything goes ECS, Cloud Lambda functions, they go to CloudWatch. From there, we set up subscriptions to the various destinations and Kinesis to funnel into the rest of the centralized logging system.
I think you should come up here, right? Lastly, we got this log rotator. The indexes are stored physically by day. So the rotator is taking older days and archiving them when needed. Any other questions?
Is there a security piece to it as well, or
In logging?
I don't know, the entire infrastructure, do you have anything like a twist lock or something that does your code validation or code validation tool or something like that?
No,
Security?
we use static analysis in that during the build,
Yeah.
but nothing in the environment like twist lock.
Okay.
Does CloudWatch get expensive?
Okay.
Has that become a significant portion of the cost? Or good?
This section.
And it's kind of not optional. Your logs are going to CloudWatch whether you want them to or not.
Yeah.
Yeah, honestly.
Do you have any other visibility outside of CloudWatch logs into your functions? Like, if it were an instance, I could log into it and take a look at what's going on inside of my application. With Lambda, do I have any visibility at all? Or just look at my CloudWatch logs?
You have logs and you have monitoring, which I'll show you on the next slide, but yeah,
That's
that's
about it.
Yeah. Which is fine, which is actually really fine. If you're paying attention to those four golden signals, right? Like
Yeah.
latency, errors, saturation, and throughput.
Yeah.
And any code change can be evaluated in that context, good or
Yeah.
bad. And you could. Okay, so for centralized monitoring, so you need instrumentation, storage, and visualization. We've steered towards less operations overhead, so we've opted for CloudWatch as our time series database, including application metrics. So we'll send custom application metrics to CloudWatch as well. And we use Grafana to visualize all that. It's a fabulous platform. It's very DevOps friendly. You can actually provision all of your data sources and dashboards in JSON and have them picked up right at runtime. And it goes through a DevOps pipeline pretty easily.
I know Kibana does machine learning. Does Grafana have that feature yet?
Probably through a plugin, but I don't know. Yeah. I've used it mainly for visualization and alerting, which is what we use it for here.
Yeah.
Yeah, you basically plug all your data into Grafana and create and share dashboards with each other. You can set up alerting based on any metrics or any variants thereof and send them off to, a bunch of different notifiers.
Yeah, you can use both Grafana and Kibana. I just like Kibana better in terms of features. Yeah.
And Kibana is very geared towards the logs.
Yeah.
And maybe they're coming more to center. Grafana is definitely trying to get closer to logs.
Yes.
So yeah, I can see.
My use case is more like that.
Yeah, definitely.
We use Kibana for application logs, so we have more metrics, with our throughput, with our latency, with our, what are the other duties you mentioned out there, right?
Yeah. Errors, throughputs.
Yeah.
Yeah.
Cool. That's it, guys.
So what kind of issues
Outside of what I mentioned, or recap some of those things?
All the one that's memorable to you, I guess.
Ian and I bid us the hardest.
The slowdown or?
Well, just when you run out of network interfaces. So when your Lambda function starts, it gets a network interface, right? The problem is, you don't have any control when that Lambda function goes away. You have no control of when that network interface gets released back to the pool. So parts of the system over here may be spinning up all these Lambda functions to handle workload, and then when it flows down the pipeline, all of a sudden you have no ENIs because they haven't cleaned up yet. Right? So it goes back to what I was saying earlier, where you have to do kind of a holistic model analysis to understand where the pinch points are and be able to control your Lambda functions with those concurrency reserve limits, so that you don't have one part of the system hogging up like ENIs for some reason, so that when you get later in the system, there's actually resources for it to use.
I forget the exact details, but they released a feature that removes the requirement for the ENI or something?
Yeah, basically the ENIs now can be shared by Lambda functions, and you have a limit now per VPC as opposed to per region, so it's
Right.
definitely gotten better.
But yeah, 6 months ago, that was a pretty hard limit. We spent a lot of time trying to figure out, who's stealing the ENIs. 'Cause in the logs, there's no real clear way to even tell how many instances you have running at a particular point in time. Unless you're starting to put, like, we actually literally started logging, like, unique UIDs when instances started up, just so we can go through the logs and be like, okay, at this point, we have 100 instances of this type running, and then later down the line, look, 50 more just spun up, now we, no real idea when they shut down.
Did you end up running Lamb stacks in all of the regions?
We actually went to multiple accounts. So part of also for our security footprint, we used to be one account. We we ran dev, QA, and production all in one account. We are now at 9 accounts, I think, roughly. So we've actually split up our production to 2 separate accounts. We do our data acquisition in one and scoring in another, and we spread that across all our environments. And then we have a management account that for the security concerns, everything funnels up to the management account. So we have all our security tools up there analyzing traffic and application logs and access logs and all that kind of fun stuff. So yeah, we didn't go the multiple regions, we went the multiple accounts route.
So have you, well, actually, is the cloud more reliable, or besides the...
The politically correct answer? No.
Okay, so have you guys had to deal with region-wide outages with S3 or the...
There was one not too long ago, like a couple months ago. There was a bad one. Not so much. I mean, they're pretty good. We don't have other than deploying the system, we don't have a huge dependency on like runtime S3. So yeah, I mean, it would hit us with like when we try to deploy a new component and S3 is unavailable for some reason. But like I said, AWS's philosophy is, well, just try again. The biggest issue we have is just like security role propagation. So like you may update a security policy and it may take 2 seconds, it may take 5 minutes before that resource assumes that policy and you get access to that. And that's really noticeable in GovCloud. It takes a lot longer for security permissions to propagate through GovCloud.
What would you say is the biggest learning insofar as using serverless versus something like Fargate?
Dealing with constraints. The 15 minutes, the memory limit, especially when we got into trying to load models into memory. One of our developers who isn't here tonight actually spent a good couple weeks just trying to figure out Python's memory management so that he could eke out every bit of memory he can.
What did he learn?
You'd have to
That
talk
was
to
not
him.
the right environment.
Yeah. He learned a lot of new cuss words. No. Yeah, he would have to give that presentation, but yeah, but that's also where we found some of the compiling. You have to build the binaries yourself with certain flags to minimize some of the footprints within that execution environment.
Would step functions fit your use case here?
Well, step functions are kind of just like workflow, right? They just tell you they just take a message and pass it to another, to another Lambda function. So we've talked about it. We do the same we had the same kind of functionality in the query plan. It's not to say it wouldn't work, it's just, one, it wasn't in GovCloud at the time when we came up with this. And two, it's, yeah.
It's not needed.
Yeah, it hasn't been needed yet. And I think we need a little more dynamic flexibility in our capability, because a lot of the modeling is like, go get this data, okay, I'm looking at it. Oh, I need to go augment it by going over here. In step functions, you really can't do that dynamic decision making. It's more of, here's step 1, here's step 2, here's step 3. You can branch, but it's a static branch, right? I can go to A or B. I can't go to C because of some decision that has to be made in processing.
Can you talk a bit about talking between different accounts? Do they charge you for file transfer?
No.
Okay.
It's all within AWS, so they, I mean, as long as you're not, even going across regions, as long as you stay on the AWS internal network
Okay.
on their backbone. Going between GovCloud and like normal AWS, yeah, then you're incurring both data costs at both ends, both data leaving the system and coming into the system, because they are completely separate.
So you have multiple accounts that have their EPC and they don't peer with the transit EPC, and
Yeah, pretty much.
Transit gateway.
Yeah, transit gateway. I mean, there's some traffic that doesn't go through the transit gateway for particular reasons. But yeah, majority of it goes through the transit gateway, so it can be monitored and audited and stuff.
I'll give you another implication of using cross accounts is if you, as a developer, require access keys and you want to assume the role into another account, if you assume role to role, you are only given 1 hour of access key time, and you cannot change it. If you assume from a user to a role in another account, you can get up to 12 hours. Okay, so do that for your developers.
Yeah. So it really sucks when you're running a playbook and your credentials expire right in the middle of it. So, yeah.
I think you guys said you try to classify different pieces of content with their type.
Mhm.
When you're doing that, are you just bucketing the bits of content into like certain groups and into certain like predefined groups that you know you're looking for? Is something that's more organic, that's understanding the relationship between, I don't know, this person and this threat type or this piece of content?
Peter?
I think it's the first one.
Okay.
But we do try to understand those relationships. It's just not always easy, and depends on the data source and what type of content we're looking for. So there's a variety of things that we do, but mainly it's the first one. It's a classification problem. In many cases, it's multi-label classification problem.
Okay.
In one of the earliest slides, you mentioned that your third parties are unreliable. So within the Lambda environment, how do you handle that? Or they take a long time to reply, or something?
All the above?
Yeah,
I mean, yeah.
it's twofold, right? It's across lambdas dealing with the rate limiting of that partner, and then failures and retrying if a failure does happen.
Yeah. So we have some data providers that hold us to a very strict, you get 10 queries a second, right? We can't, no matter how big our load is, we can't go faster than that. There's other sites that have quote unquote open access, but we've actually brought their servers down because we went to them. So, there's the being good internet partners and throttling our requests with them. And then, as with any web scrapers, you've got sites that are just, you hit Bloomberg too many times in a minute, they're just going to start blocking your IP address, and there's nothing you can do about it, right? So you got to deal with situations like that as well.
So the Chromium instance, the Puppeteer thing,
Uh-huh.
is that running within a Lambda?
Yep.
So they block you, right? Can you use it in Lambda to get around the IP address restriction?
Nope. Well, not immediately, because Lambda functions to talk to the internet, so they'll have to go through an internet gateway or a NAT. So they all still look like they're coming, as long as they're part of the same VPC, the same route tables, they're all going to be looking like they're publicly, they're going through the same IP address.
There's no workaround for this?
Sure, you can stand up separate VPCs, separate NATs, go through different regions. Yeah.
From a business perspective, it's also important to honor our partner agreements and to to be good internet partners, because if any one of those data sources cut us off, then, which they're all getting better at figuring that out, if any one of them cut us off, it hurts our business. So that's something from a business perspective that from day one, we have always honored user agreements, partner agreements, and any of those other pieces in between to ensure that we have continuity across the board.
This is a really minor thing, but do you guys know if AWS gives you any metrics on how often the Lambda functions that you guys invoke will warn or not?
No. That's why I said we were literally logging UUIDs in the module startup to get that information, you know. And then every time it got invoked, it would dump that UUID so we could see it started here and then it started serving these requests. And that was kind of the only way we really could get a handle on E&I usage and, you know, like you said, knowing when things kind of shut down. So we know things if idle for about 15 minutes tend to start cleaning up, but
some people have deployed things like, you know, warmer functions and things in Lambda. I mean, at that point, it's not really serverless anymore.
you're not getting the cost benefits of.
Cool. Any other thoughts, questions, comments? Yeah, one more.
So you were saying this is Aurora on the database side, but this is old Aurora. This is Aurora non-serverless.
Right now, GovCloud doesn't have serverless Aurora, so it's all server-based. We have some back-end stuff, like I think our RunDeck servers are running serverless because those are only on the non-GovCloud side. Yeah, or we can get away with it. We try to go with the serverless, but GovCloud's anywhere between 6 months and 3 years behind. They just got Route 53 about 6 months ago. Yeah. They just got DNS. So,
Caused all kinds of problems.
yeah.
What's RunDeck?
Oh, what's RunDeck? So,
RunDeck is Jenkins for operations folks. So it's environment aware and provides an operations console for us to enable support engineers, customer success reps to come in and take action in the environment. It's got full logging and auditing capabilities, so if something happens and it's executed through RunDeck, we can clearly go and see what happened, all the log output, everything.
Does it do forensics?
Come again?
Does it do forensics?
In what way?
Like, if something happens, does it give you, just trying to understand, does it give you what happened?
It does. I mean, it's very much, I was going to say like Jenkins, but not really. They're both just kind of table jobs. But in RunDeck, you can go through and you can define the nodes you want to discover to execute the program on, to do whatever you want. And all of the output from all of them are consolidated in a log. It's all access controlled, so we log in, we know it was you. It's deployed and built by the engineers and the operations engineers, so that everyone on the team can go in and perform the same action the same way. There's no somebody did something by hand or ran a custom script they wrote. That's the operations way of doing things. You go in, click the button, that's it.
Right. Okay. Thanks.
Is there anything like an orchestrator Lambda, or is it just one chain? So is it all just a single chain?
I kind of breezed through it in the beginning, but the query plan that I mentioned, right, that is the definition of that pipeline. And so one search goes through for that organization, it figures out which lambdas, which models, which databases, which sites, all of that, and then goes and runs it.
Okay.
Yep.
So you created your own DSL?
pretty much. Yeah.
Okay. Thank you so much, Ryan. Okay, awesome. Hey everybody, my name is Lauren and I work at Hat IT and we just help organize these CC Python meetup events. So thank you so much to DynaMic and for Brian presenting with us tonight. I just wanted to let you guys know real quick about a platform that we're going to be launching in January. And it's just going to be a website where engineers can connect with one another. It'll be a place to learn more about meetup events like this, but also if you want to get involved in different ways to volunteer in the community, we'll be sharing that sort of opportunity on the site as well. And then another component will be if you have any side projects that you're working on and you're at a place where you want to be able to kind of showcase it and share it with others in the tech community here in the DMV, there'll be a place for you to do that as well. So feel free to grab me at the end of the event if you want to hear more. I can kind of give you some more details. And then I think last announcement is just feel free to grab more food. We have some leftovers. So thanks, everybody.
Thanks. Thank you, Ryan. Thanks, Roy.
I didn't get it.